So yes, hi, my name is JJ Asghar, and I've spoken here a handful of times. I'm here to talk about the InstructLab project, and as I said, my name is JJ Asghar. I have the email addresses of awesome@ibm.com, and let me just ask real quick, who's here to learn about AI as a general thing? Like, do we feel comfortable with AI as a whole? Are we in the right room? No? We got one. Okay, cool. Well, so I've done this talk a handful of times, and I've learned one of the biggest challenges is that a lot of people are engaging in the AI space, but they don't fully grasp the most basic understanding of what AI can and can't do. So I end up taking this conversation, because it becomes a conversation with the audience in a way so you can feel comfortable enough to be able to engage, to see even if AI is what you need, right? With all new shiny tools and all, there's some really important things, and people want to gravitate to it because that's where money is, et cetera, et cetera. But I've learned, I want you to, walk away with something valuable. So I'm hoping after this 50 minutes work together, or I guess less than 50 minutes now, but that you'll walk out of this room and feel at least more confident to realize, oh, Jesus, that's really bright. More confident that AI might make your life a little bit better, or, you know what? Let all the VCs go after AI and don't worry about it anymore, right? It's going to be one of the two. That was a joke. Nobody laughed. Awesome. All right, again, I'm a developer advocate at IBM Research. I know developer advocacy means nothing anymore, but, hey. Oh, nope. Maybe no. How about now? There we go. There we go. Okay, cool. But yes, so let's get on with it. But before I start anything, I have to justify me being here because IBM does send me to places. So please, if you can, take a picture of that QR code. It just sends you to ibm.com/granite, but it hits a counter to say that, yes, JJ was actually talking to people at a presentation. It makes my life a little bit easier and allows me to do this a little bit more. Thank you. I just need a handful of people to do it. But in all seriousness, Granite is basically the same thing that DeepSeek is, but it's run by IBM. And as the joke says there, you don't get fired for buying IBM, right? Right? You never get fired. Anyway, okay. So, okay, let's continue on. So, when you start playing around in AI, in the AI space, there are two very interesting terms that pop up very quickly. Everybody can go to ChatGPT or whatever and inference against an AI and ask it a question, Go write me a cool sonnet about why, write me a sonnet about why Kubernetes is cool, right? It'll come back with a sonnet. And you're like, hey, that's really, really useful. What do I do now, right? Like, you've got to figure out something else. People have learned how to do, the co-pilots of the world to be like a nice little intern that writes a really good for loop for you or some shit like that. But there's more to it, right? And one of the ways I describe AI to people to kind of let them grasp the concept, and it's really important before we get to InstructLab to lay this groundwork, is that if you imagine an AI as a librarian, right? So first of all, did you know, librarians keep the world going because they control, or they help find us knowledge. Librarians are actually professional researchers. That's what they do, right? They went to university to come out as some of the best researchers on the planet. So if you imagine your AI as a librarian, they know where all their books are in the library, right? Or they know where to find the information inside the library. But they also have a bunch of knowledge in their brain, right? Like they know that the sky is blue, or George Washington was the first president of the United States, right? And occasionally you're going to need to ask, like, hey, librarian, who was the second president of the United States? They might not know that. Well, they probably do, but just bear with me. So they're like, okay, you know what? I'm going to go find the knowledge in the library and bring you the book that has that knowledge. So the librarian runs off into the library, finds the book, and pulls it out. and then finds the information and then tells it back to you, right? Now, that library right there is what we call a RAG, right? If you ever hear the term of a RAG, or a retrieval augmented generation, imagine it as that library. It's slower, right, for the librarian to go find the book and pull it out and find that knowledge, but that's what it is, right? InstructLab is something called fine-tuning, which is if you take that librarian, instead of sending it back to the library, you send them back to university to learn something new and have it injected in their brain. Now, real quick, if I need to add new knowledge so that this librarian knows something, is it more expensive to put a book in the library or send them back to university? Anyone? University, yes, of course. It's more expensive. You've got to send them back to university, right? But that's what it is. Fine-tuning is an expensive process to give more knowledge to a librarian, or to the model. Now, it's important to recognize, though, that model now has it in its brain, so it doesn't have to go and find it really quickly. So if you imagine that paradigm, as we talk about fine-tuning using InstructLab, you'll understand the value of it. But, obviously there's a cost benefit to this, and it's important to recognize that. So what is InstructLab? It turns out, sending that model back to university, or librarian back to university, there are a lot of different ways to do that fine-tuning, the actual technical aspect of doing it. And InstructLab is an opinionated workflow using open source tools to be able to actually do this. If you go on to YouTube and look into fine-tuning, there's a bunch of different ways of doing it. And Red Hat and IBM, well, it was an IBM research project that Red Hat we donated to Red Hat and Red Hat now owns. That gives you the ability to slot in different portions of that workflow of fine-tuning and to be able to distribute and create that new model. So in order to get started with it, you have to have a base LLM. You have to have a base model. And then you grind through a process of, you take the model, you have another teacher model that takes a bunch of questions that have a spirit of what you're looking for, some new base knowledge from that. The teacher model creates thousands and thousands of questions through something called synthetic data generation, and then trains the new model, or the student model, the new knowledge it needs to have. Okay, so bear with me. It gets a little confusing, but what happens is, imagine me being the teacher and you being the student. I start telling you thousands and thousands of times that the sky is purple, right? And I have all this knowledge behind me to prove to you that the sky is purple. You as a student get the weights changed in how you understand how all this is done, if you will, the database of your knowledge, because it's all just one big graph. Eventually, you understand that the sky is purple. And then, from there, you become a new model with the new knowledge that the sky is purple. Again, it's a horrible example, and I couldn't think of anything better at the moment. I think I've got the Fosdem flu, unfortunately. But it is one of those things where if you imagine that way. Now, we also, the best part about this is, who loves YAML? Y'all are all lying. By the way, I met the guy who wrote YAML. His name is Toy, something like that. He was at KubeCon. I have a picture of that if you want to see afterwards. He's just like walking around Cube. Anyway, point being. So you have these YAML files to be able to create that synthetic data, and we'll get to it. I'll get to an example of using it Mudang here in just a second. But let's talk about some of these portions of the project quite quickly. So as you start building up as you start trying to train the model with new knowledge or new skills, which I believe is the next slide. Skills, and so, okay, with all of that preface, the core value of InstructLab is the opinionated workflow that gives new skills and knowledge to to models. So one of the biggest problems is that AIs are not human, right? So they only know about the things they've been trained on at the time and the skills that they have at the time. Like, they don't continually grow. They're points in time. So eventually you're going to need to add new skills. You're going to need to eventually add new knowledge. And with our opinionated workflow, you can add new skills and knowledge. What is a skill? It's a little hard to grasp without understanding what a knowledge is first, so let's talk about what a knowledge is. A knowledge is the ability to add new knowledge into the brain, or the model. It's brain. The metaphors fall apart as soon as you start talking more and more about this, unfortunately. A skill is the ability to take different bits and pieces of that knowledge and create new ways of either ingesting it or excreting it. What would be the opposite of? I don't know. Anyway, trying to think of a better word than excretion, of that knowledge out. So if you imagine one of our best examples we've come up with, do we know what double book accounting is? Do we know if you know double book accounting? We got a couple? Awesome. So there's like a new project out there called Bean Counter that does double book accounting, right? It's pretty obscure, but it turns out it's a really good example of being able to teach a new model, a new skill. Because it's so obscure, but everybody understands double book accounting, you can leverage the Bean Counter output, so you can train these new models on how to do it a very specific way of, instead of doing double book accounting out. And all you have to do is put in a simple YAML file and train it on how to do it. And I'll show you the YAML files here in just a second. I know this is so convoluted, but as soon as I show you the code and I'll walk you through a couple of the things, it'll make more sense. But this is the AI industry we live in now. We thought Kubernetes was hard. Trust me, this AI stuff is even harder. Hey, somebody laughed. That's perfect. Thank you. Okay, so out of all that, believe it or not, we're going to talk about Mudang. Do we know all who Mudang is? Is this just because I'm a Gen Z thing that my kids know that I don't? Great. Okay. All right, so if you didn't know, Mudang was the pygmy hippo that was born in Thailand? Something like that. Thailand last summer. And it's a perfect example of adding new knowledge to a model. So, as I was saying earlier, models are trained, and they only know about things up to the point where they know about. So, the model we use is something called Granite, which is the one we showed earlier. And we were able to train our model with a very simple knowledge file and YAML to be able to actually gain the new knowledge of Mudang. And we're going to talk about how we did it right now. So, first thing first, let me show you some code. All right, so here we go. Can we all read this? Okay, so this should look very familiar very quickly. Yes, it's YAML. This is a knowledge submission. So what you have is some metadata. You have something called the seed examples. This is the spirit of the questions that you're trying to add to a model. You have something called a context. So when the teacher model starts trying to get new questions, it knows some questions and answers from a context, so it knows where to look for in the file. So when it starts reading the file more, it kind of understands that it needs to go. It's very black magic, and you're probably like, JJ, what are you talking about? I don't fully grasp it myself, but it works. So, don't look a gift horse in the mouth, or don't look at a gift hippopotamus in the mouth. Nothing? Somebody laughed. That's what I needed. Thank you. All right. So as you see here, you added some questions and answers, right? Question, who is Mudang? Mudang is a pygmy hippopotamus living in Thailand. I did get that right. Awesome. And then you see here's the context. And you do about 15 or 20 of these questions and answers, right, to give it the spirit of what you're looking for. And then you attach a document to it, right? Good old Charlie here, good friend of ours from Red Hat, published a document with just a simple markdown document with the knowledge and a Git SHA attached to it. I'm pulling out the Git SHA to be a very specific point because knowledge moves, right? Same as with code, same as with documentation. So you need to be able to tie the best way we can. We decide to use Git, a way back to know that this knowledge submission goes to this very specific revision of this knowledge doc. That is very, very important because, you know, things move. So when we throw this through the workflow of it, which is out of all of this presentation, by the way, I'm going to actually show you the models here in just a second, but this is the most important picture or whatever of the InstructLab workflow. What you do is this, what I just showed you is a contribution page, a portion of it. You take that YAML file, and then you run that through the teacher model, and the teacher model comes out with the static data generation, the SDG, of those thousands of questions. You train the student model off of those synthetic data generation, and then you get the file, and then you get the model out of it, and then you get to go through this cycle all over again. Now, there is the conversation of an upstream taxonomy, of us building a community model that we know for a fact has been built in an open source manner. We are in the process of attempting to bootstrap that project again. We tried it back in May. We had some hiccups, and it turns out one of the biggest problems we realized is that we were biasing our model on US-centric information, which is not great to try to build in a global, transparent model. So we actually started to roll that project back a little bit. How did I know this? One of our best examples that we were getting put in for knowledge submissions, i.e. the Mudangs that I just showed a moment ago, were dad jokes, and US-centric dad jokes for that matter. I have made some of these dad jokes today in front of some of y'all, and y'all have not laughed. So it just shows that we have a problem with US-centric Western culture, and we don't want that for our global project. So we are trying to find a better way to be more international, or more sensitive to international cultural differences, which is a challenge. But why am I saying all this? The competitors are out there, the ones in Redmond, the ones in Silicon Valley. Do you think they would spend the time and effort to try to figure this out? To figure out a way to have a global, you know, a global culturally sensitive AI? No, they'll be okay with just using, you know, US-centric Western-based things. IBM and Red Hat have identified that what we are creating is something for the world, not just for, you know, the VCs. Anyway, okay. So let's roll back for a second. Let me actually show you some code. And the first thing first is I have two of these models here. Everyone knows what a GGUF file is? Who does not know what a GGUF file is? Okay, cool. So when you build models, or when you start playing around with models in general, there are two different file formats that you'll see quickly on something called Hugging Face. Who does not know what Hugging Face is? Awesome. So you will see something called a safe tensor out there, and then you'll see GGUFs. There's other formats too. I'm just big wide swath here. The safe tensors are the unquantized. Who does not know what quantization is? Precision? Good. So the unquantized model is usually done through the safe tensors. And the GGUF is a quantized version of those safe tensors as a binary file that you can run on your machine locally. If you look, they are about 4 gigs each, right? So to get the model, when a safe tensor is upwards to 10 to 15 gigabytes, right? So it is a significantly smaller file, the precision quantized down to run with GGUFs. Now, why am I harping on this? It's because we realized that if you want to run InstructLab to do successful training with models, you actually need to run it in the unquantized way. Like, our way works. We have proven it over and over again. But as soon as you bring quantization in, or making the GGUF files of it on your laptop, you have a bad time. It's because it knows a lot of stuff. I've decided to teach it about Mudang. Mudang's brand new, so there's not a lot of stuff in there. But if I need to change knowledge of there, like for instance, the sky is purple, again, a horrible example, but I can't think of anything better. There's a lot of places in that vector database, or that plot graph, that knows where the sky color is. And it only changes a small amount of that to get that new knowledge, or change that knowledge. When you quantize it down, that precision gets smaller and smaller, or the precision gets smaller, larger. Larger precision? The numbers get small. They cut the numbers off to make it smaller, right? So if it's changed all these points, but all the points are on the outside of the graph of UL, and you just cut the graph away, it only knows about the sky is blue because it didn't get the changed bits. Does that make sense? Because if you imagine it as a graph in your head, and you've only changed numbers on the outside of the graph plane, and then you cut all those away to make it small, the file smaller. Now, all the changes you just did disappeared, right? Which is weird, right? So you spend all this time training the model, and as soon as you quantize it down, you just cut away all the work you just did. Thumbs up? Following me here? Yeah, okay. Which is a problem, right? So that's one reason why our laptop story, because what we use is something called Aurora. So everyone knows what a Docker container is, right? If you're not a config fan, you know Docker containers. We got a lot more of a conversation we should have. Well, so the Aurora process, which is not using the safe tensor file, it actually uses GGUF files. It puts, if you will, another layer on top of the GGUF file to change those weights. And that's another big problem, is because that change is so minimal compared to that 4 gig, that as soon as it tries to bring it smaller down to quantize it, I can't say that word now, quantize, make it smaller, you lose those points on that graph because it's trying to make it smaller. It's a really hard problem to have. So, let me go ahead and spin up our first version of it. Oh, nope, not that. Right here. I'm going to run the untrained model of the code, and I'm going to use the trained version of it again. I'm going to use iLab, which is our CLI. And excuse me for a second, I got a cough. And then I'll use the next one, and we'll see the difference. Now, it's just literally putting new knowledge into it, but you'll at least see the workflow that we go through. All right. Serve. All right. All right, so as you see here, I've got it running. InstructLab is more or less all written in Python too, so if you have any basic Python knowledge, you'd be surprised on how quickly you can grasp what's going on inside the project, which is really nice. chat. So here is me getting into the chat system, or the chat interface to InstructLab. There's other ways of doing this. I'm just using the normal tool. You can use anything LLM or Open Web UI if you want, because we've standardized on certain things with the OpenAI API. God, I hate that name. And then, so it's standard, but just show for brevity's sake, I'm using this. So if I say, who is Mu Deng? Just like that first question we saw on the YAML file, right? Who is Mu Deng? As you can see, it does not know, right? It thinks it's a Chinese character about a journey, about a gamer of legendary figure in the world of Warcraft. No, that's not right. I thought this was a hippopotamus, right? So I go ahead and quit out of this, and I come up here, and fast forward, or now we got the new model, we got Charlie's thing, we did the dance, we trained it, and then we came out with that new GGUF file. And I bring it up. And one of the things that needs to be very clear is that every time you run through the workflow, the new model you have trained is a new binary, right? It's not taking the original model and then shoving new knowledge into it, and you can use the original model again. It is a brand new file. Now, that brings up a very interesting question. How do you know you haven't, poisoned the model, or whatever along those ways are? One of the advantages of the InstructLab project, at least for our public conversation, is that everything is on GitHub, right? As you saw, as I showed that thing up there. But if you have an enterprise or a company that needs to be able to leverage fine-tuning models for, your expense information or your HR documentation or, whatever reason you need, you can have a shared resource that you can see over time as you build out the model because you're using Git, again, back to those SHAs to know exactly where that documentation is with. That make sense? Thumbs up? Awesome. Fosden flu, man. Fosden flu. Model. Chat. Okay, as you can see here, new version, awesome, great. I'm going to go ahead and ask that exact same question, who is Mu Deng? And there you go. That's not right. Hang on. Let's try that again. Don't make a lie out of me twice. There we go. There we go. Oops. Scroll up just a little bit here. There we go. As you can see, and I believe what has happened there is a perfect example of that quantization problem, right? Where it's still, like, I only did a small amount of that. I mean, we only did one file with a small amount of data inside of it, so it still had something about Mu Deng in the back of its brain, if you will. But luckily, we caught it there too. So, as you can see, it's not 100% accurate, but pretty close, which is nice. Which is, again, if you look at the amount of knowledge we have added to it here, excuse me. It's important to recognize that this is all the data, which is actually pretty big on this, but if you look at how big the document is on a normal size, it's not a lot, right? So you have to understand, the more knowledge you add, the more data you can add to it, the better questions you can have. That requires some experimentation. And that's the reason why I started the conversation with the difference between fine-tuning and RAG, is because you've got to experiment with this stuff. You've got to be able to get to the point where the model understands what you are looking for. There's a push and a pull here. Depends on how much you want to send your librarian back to university and how much time and effort it takes. Training that model on my Mac M3 took 17, 18 hours, if I remember correctly, and that's with a $3,000 laptop, right? That in the space of in space of infrastructure, in the space of places where you all iterate on machines quickly because you want quick, fast feedback loops, training a model to find out that it got a 50% accuracy rate there, that's not great, right? But if you take this exact same thing and not use these quantized models with completely unquantized, full precision on real hardware, by real hardware I mean like real GPUs with like A100s and H100s, you get a phenomenal feedback on this. And it only takes, a couple hours compared to 18 hours, and you get what you're expecting. I know this because I've actually had the privilege of actually running this on 8 A100s, which is really nice. So there's a push and pull here, right? Like, how much do you need to give that librarian that much knowledge in its brain? And I'm harping on this because when people get into this space, they think that having a massive model that knows everything is the way to go forward. But that's the model that's going to, boil the ocean, because as you gain more and more knowledge in the actual model, you need bigger and bigger hardware to run it, right? Because it has to all fit inside of the GPU, which means you need to burn more power to it. So what becomes the trade-off? Do you need bigger hardware with bigger things to train it so it knows things really, really fast? Or can you use a RAG and have a smaller model that is specifically trained, if you will, a micro LLM? Yes, that is a horrible name, but what is it better? It is a small large language model, right, that is specialized in very specific things. And this brings you to the natural progression of the agentic workflow. If I say the agentic workflow, who does not know what that means? Okay, so as you start going down the fine-tuning ecosystem and you start realizing that models are expensive to run or are challenging to run, when you start looking into things like InstructLab, which I should probably have the slide up for this. When you start looking into the expensive parts of running agents and actually looking to productionize things, you start recognizing that having small models that do things well, just like back in the Unix days, do one job and one job well, having small models to focus on certain things works that way. The agentic workflow is the idea of leveraging something called Crew AI or B agent out there, which are the two main frameworks. That what you can hand off is you can have an agent that only goes off and knows about your HR information, only goes off and knows about your product documentation. And then you have another agent that knows to hand off that question to that other agent. So look up Crew AI or B framework from IBM. Obviously, I'm going to shrill IBM when I can. Oh, that was a joke. Nobody laughed. Great. And the ability to leverage these. So you have a bunch of small LLMs that it turns out nobody ever uses your HR one. You don't need to just have it sitting inside your GPU burning energy, right? You can unload it, and then when a new agent needs it, it spins it up and starts it up again. Does that make sense? Cool. So I do want you, if you can, take a picture of this QR code. And as I said, in this presentation usually turns a conversation because we take little weird turns about what all this space means and whatever it does. this is a URL link to the GitHub, where you can actually join the community and be engaged. But I do want to leave the rest of our time to have a safe space about this AI stuff. Because I know everyone in here, especially when you rose your hands, there's some very fundamental things that you may not know. So let's actually talk about it. Or I can even show you some stuff about how to do this. I am more than willing to go in any direction on this because InstructLab is I'm literally wearing the t-shirt, right? I'm very cold though, so I have 3 jackets on. But I really do believe in this project. This is, out of all the AI space right now, everyone's building AI in their walled gardens, right? Like all the different companies out there are investing a lot of time and effort into it, but they're building it in a way that the open source ecosystem can't see in. What does that mean? We don't know the biases that are going to happen. We don't know if this is going to be the thing that's going to, frankly, hurt us in the future. At least with what we're doing with InstructLab, we have a pane into what's going on. We actually can see the story that's actually being created, so we can have those conversations and actually work towards that. Cool? Yes, please. Yeah. Yeah.
Let's run agent and hope this actually does something that I'm not sure I can.
Yeah, no, that is a wonderful question. So just to repeat it, so everyone hears it, if I build up a chatbot, and how do I make sure that it actually gives me accurate information, right? So there are, believe it or not, there are actually bots, or there are models out there that are designed to make sure that other models don't completely go off the rails. So you can give them parameters to make sure that they are within the realm of the conversation you're trying to have through it, to be able to keep it inside the space. But if you're looking for very specific knowledge, like for instance that Mudang one, that is the experimentation of fine-tuning that you've got to do, right? So you've got to, obviously that wasn't enough knowledge. That document that Charlie put together wasn't detailed well enough. And also we need to add more questions and answers and play with the questions and answers to make sure that when all those questions are created from synthetic data generation, when all those questions are created from synthetic data generation, they overwrite the correct weights. The problem, what you're maybe what I'm hearing and the way to answer your question is that a lot of people out there assume the ChatGPTs of the world are just going to take over questions and answers, right? You're just going to be able to ask an AI very specific things and it'll give you exactly the answers back. What we've learned through this technology is that that's not true, right? Like you can get 85, 90% there with a lot of this work, but there's no way you can tell that it isn't bullshit without verifying what comes out of it. That's the reason why if you use Open Web UI, anything LLM, for that matter ChatGPT, there's always a little line at the bottom saying you should validate whatever this comes out of the LLM because you can't completely trust what it says. There are people out there who use the sat-nav right on your car. At least in America they do. And there are people out there who will literally not pay attention to what's on the road and just do exactly what sat-nav says. I mean, it's a meme, but it's true. These people do exist. I know some of them. It makes me very sad to talk to them, but it's a different conversation. And unfortunately, chatbots have brought more of those types of personalities out, where they've just trusted exactly what comes out of it. the best thing we can do is experiment as technologists to be able to get the things we can look for. A perfect example is the whole conversation of using things like Copilot or whatever to write code for you. People just copy pasta that Copilot stuff and put it into production now. We used to copy pasta things from Stack Overflow where at least you got to like vote up yes or no, that it's a relatively close answer. But now people are just copying pasta directly from ChatGPT and putting it in production and wondering why things are going wrong. And that's the same kind of problem, right? Like, you have no way of knowing. You have to verify what's going on. Did I answer your question? Go ahead.
I was wondering more about the I don't know, airline support. This is everything is like an AI thing. But I mean, you kind of answered it in the way that like it's not like it cannot guarantee that it's going to be correct. So it should not ever be used in a context that requires things to be correct. It's like, yeah, support.
There's a conversation that you need to have with your business partners about what is our acceptance of pain, right? Like, is it bad that they send us to the wrong wiki page? Or is this a piece of software that's going to be answering like 999 calls, right? Like if you have a chatbot that's going to be life or death for somebody, obviously you want it to be 100% right all the time. But if you're going to be like, where's our expense report information? And it gives me, you know, the wrong wiki page on Confluence, that's a much different conversation. And unfortunately, there's a lot of people out there who want it to be right 100% of the time, no matter what. And this technology just isn't there yet. But using things like InstructLab, we're at least stepping towards there in an open source way. And we're trying, we desperately are. Granite, just to plug Granite again, is one of the best ways for us to find it from an international conversation because it supports multiple languages, it runs on your laptop, and it's like 85%, 90% ChatGPT actually works. And it's pretty, in the grand scheme of things, it's quite nice. But it only has its knowledge, what it has trained up to since April of 2024. So if anything's happened after, for instance, there's something that happened in the United States I don't want to talk about, we need to train Granite on that now, right? So we have to add new knowledge, we got to keep moving forward. Does that make sense? Cool. Yes, please.
What's the status for other languages than English?
Ah, great question. So that, when the question is what other languages are out there, apart from English? Every single model has a different iteration on using different languages. I can speak closely to Granite, has, I believe, 80 different languages now, or something like that. Or 8, something like that. They have every single model has to have new trained data to build new versions of it. Sorry again. You know what, how about I just bring it up real quick. IBM. It used to be right here. Oh, of course, they changed the website between the last time I looked. But the point I'm trying to get to is every single model out there. So if you go to the Microsofts and look at Phi, you go to DeepSeek or whatever, it is up to them to choose what languages to support and train on those to get there. So you've got to do the research on the model you want to use. InstructLab, the workflow, if the model knows the language before you putting it in as new knowledge, then it will work. But you cannot train a model that only knows English with a new language through the workflow we've done because it doesn't associate grammatical issue or grammar and how the language, it basically translates the English words into the other language and has no grammar to it. We've also noticed that problems with non-Arabic characters, like our friends in China, our friends in Japan, friends in Korea, when they try to put their lexicon into these questions, the AI model has no idea what to do. Did I answer your question?
Yes, sort of, because one of the strengths of the other competitors is that they actually use their knowledge and formulate it in whichever language. So even if it was trained with knowledge in one language, it can apply that knowledge and provide in Norwegian, for instance.
Yeah, understood. That is an accurate statement. But then I go back to, they've been trained on that knowledge, but you don't know what knowledge, like you have no visibility into, first of all, what knowledge they're taking from you, from the things that you just gave it. Also, like what knowledge that origin came from, right? There's, one of the advantages of our open source models is the visibility into it, which, that's a trade-off, right? I hear that you have something called the GDPR here in Europe. I hear that's a big thing. In America, we don't give a fuck about this stuff, but here y'all do. How do you remove knowledge from a model? Do you know? You can't. You cannot. So these models that now, if you accidentally send some corporate knowledge to our friends over at ChatGPT or whatever, and then you try to hit them with a GDPR removal, there's no way to do it. Like the technology doesn't exist. You can only add stuff to these things. Yeah.
I don't remember his name, but it was from
Yep.
big influential rich family something. But
Yep. It's a real problem, right? And that's one reason why, like, we need transparency into these things. Everything with Granite too, and this is my. If I use the term elevator pitch, does that mean things to everyone here? Thumbs up. My elevator pitch with Granite is this simply said. We know as IBM, everything we did put into these models are open source, copyright non-infringed, attributed correctly, and we will put our lawyers in US court to defend if you get sued for copyright infringement off of this thing. And what is IBM famous for? Yes, I'm gonna say it, our lawyers, right? If we're gonna put our lawyers behind this thing, that means how serious we are about it. Our competitors over in the other companies out there, are they gonna do that for you? No, they won't. They might claim they will, but we will actually do it. That is our promise with this thing. So if you want to have something that's, you can build a business off of, this is what you're looking for. Anyway, what else can I answer? Mm-hmm.
What if you end up in a certain, like, maybe this is more of an academic question, but what if you end up in a situation where you can't really add more knowledge to the model about something? Like, you just have to kind of, like, okay, I have a list of characteristics, but, like, there's no, like, story or, like, true behind something. That is just what it is. Do you have any other techniques in order to, like, sort of increase the accuracy of what your model is getting at?
So, by the way, he's my brother, and he just was a dick for asking that question. So one of the core understandings of how a model finds, okay, so when a model is adding the next sentence or next word out of what's going on, it uses a multi-vector graph, and it looks for the highest percentage of what it needs to add to the next thing. And that was that whole quantization thing, right? There's this massive graph that all this information is in, and then it looks for the precision to pull out, oh, you're asking about green apples. Well, a green apple is sour, and there's the version of the Granny Smith apple. So it looks in that graph, and it sees a bunch of things about apples, and it sees Granny Smith, and it sees sour, and it sees where that intersection is. And it realizes that's all this little information needs to be there, and it pulls it out, and then writes out English, or whatever language sentences for that to give you the information you're looking for, right? If it's brand new knowledge and it knows nothing about it, there's nothing that intersects and be able to play off of what's going on. And that's where that I'm a professional speaker. Hallucinations, thank you. That's where hallucinations come from, because it's trying to find where those intersections are in the knowledge, but then because it doesn't know, it knows so little about the space, it touches so many other things, it goes off and adds more things to it. As a developer advocate, I actually used to ask, as one of my examples, when to try hallucination, thank you, on how these models are just have problems. I actually used to ask it, what is a developer advocate? And he used to say, I worked for the CIA for President Obama to travel around the world to present about technology. I mean, it got kind of that right, right? But that's the hallucination, right? Is that it knew that I traveled the world, talked about technology, but obviously I don't work for Obama, and wink, I don't work for the CIA, wink. But you see where that's going, right? It picked up this amount of this knowledge and only knows about this space. Go ahead. Yes, actually, there are AI models that recognize that it only has a limited knowledge and it will shut itself down. Granite has done this to me myself, actually, saying that it doesn't know it.
You give it a topic like someone could be like, all I know is where they were born and what their name was, without being enough information for the model to say something about it instead of just fabricating it.
So that's where the push and pull. My flight's going to be terrible going home. That's where the push and pull of a RAG and fine-tuning come in. So if you only had, I knew this person lived 200 years ago in Ghent, Belgium, and this is their name, but you had a RAG with all of this information about the census of here in Ghent, things happening in 200 years ago, and their name. The AI model, not immediately, there's still a little bit of engineering work that has to happen, but the AI model could, if you will, be the librarian and go find all the knowledge around that to be able to pull that information out and give you a summarized as close as it can get to the data it has in the RAG to pull that information. Perfect example of exactly what you're saying. I have a dream idea of one day, I'm trying to get people behind me on this one, is Congress.gov at the United States, they release their bills almost hourly as PDFs on their main website. I want to be able to scrape that website, take all those PDFs, put them in a RAG, and then use our open source model as an entry point so I can actually ask it about, you know, what bills are being put in for the US budget or whatever, right? Being completely true open source. Because if you didn't know, the US budget PDF is like 900 pages long, right? Who actually reads that? Nobody actually reads it, right? I mean, it's a bad joke, but it's true. If I had Granite giving me summarizations of what's going on, that's a value prop there. That's a greater good thing that I can play with. To play off of what you're saying is the exact same principle. And I would be ideally updating this like weekly. Did I answer your question? Awesome. What else can I answer? Please. Say again? Is there a testing framework for a model? So there's something called MT-Bench and MMLU. Yeah, MMLU, thank you. MMLU bench, which are some agreed upon questions about general knowledge and general facts that all the major models now benchmark against to say that, oh yes, George Washington was the first president of the United States or whatever. And then it can mark it against it. There's actually an arena, if you will, of models out there that they fight to get higher and higher numbers on these questions to kind of answer it. But that's the best testing framework that exists. One of the beautiful parts about InstructLab is that when we push it through our system, we see numbers go up when it adds new knowledge, which is nice, because now it has new knowledge about something or more detailed knowledge. Did I answer your question? Yes. Awesome. What else can I answer? The one thing I want to leave from, hopefully, if you're at all interested about this also, and you don't want to just ask your question now, I'm going to be meandering around. Please don't hesitate to stop by. I have a couple other use cases that I like talking about leveraging Granite for, just if you're like, why would I ever do this, spend the time to do this? So I have no problem talking about that. But the best way to learn, it was just like when Kubernetes first started, right? Like, Kubernetes hit the market, and we're like, why do we need this? We got VMs, right? Like, it's all we need. We got containers. Docker Swarm works, right? Like, why would I mess with anything else? The best way to learn anything about this AI stuff is to play with it. I'm not going to tell you to install like all this stuff on your laptop. I'm not going to tell you to do this. I'm telling you just to like leverage it to see if there's little bits and pieces and make your life a little easier. And before you know it, you're running anything LLM with a llama on your laptop, and you're like, hey, maybe I can make it do this thing for me. And then all of a sudden you're like, hey, that just saved me like 45 minutes of my life. I could have watched a TV show then. That'd been nice. All right, thanks, y'all. Oh, sorry, go ahead, Carol.
Tomorrow there's a workshop for InstructLab, one o'clock in B3013. It's in the schedule.
Yep.
Yeah, and you just have to bring your laptop. It's browser-based, and you can come anytime one or later. It's not like I don't just start at 1, I can start anytime. It's self-paced. So welcome to that. And there are InstructLab stickers and editable them because I don't have InstructLab. So